First of all, welcome to this discussion panel. I know it's cold and everyone's busy, but thank you guys for coming. I have one quick announcement. The Graduate Student Professional Development Series is coming up on this Wednesday. You can contact Casey Cockrell, or you should have gotten it in your email for more information on that. And our speakers today, Tamara L. Goulet. She came to the University of Mississippi in January 2001. She studies symbiotic systems, focuses on coral reefs. Dr. Goulet currently has a National Science Foundation career grant to research symbiosis of Caribbean octocorals. In addition to symbiotic research, she has NSF funding to conduct
pedagogical
research and promotes teaching innovation. Dr. Goulet publishes scientific articles pertaining to coral reef research and pedagogical research. She also acts as a reviewer for numerous peer-reviewed publications, including Nature and the Proceedings of National Academy of Science. In addition, she is an associate editor for the scientific journal Marine Biology. She therefore has experience as an author, reviewer, and editor. Lastly, Dr. Goulet publishes articles in the popular press explaining science-related topics to the layperson. Next is Dr. Ajit Sadana. He received a BTech at Indian Institute of Technology, Kanpur. Then later received an MChemE, University of Delaware Network in 1972. In 1975, he earned his PhD in chemical engineering at the University of Delaware. His present area of interest are analytical receptor binding and dissociation kinetics on biosensor surfaces, biomarkers for diseases. He joined the University of Mississippi in August of 1981. And lastly is Dr. Charles L. Hussey. He is the chairman of, and professor of the chemistry department in university. His research experts include the electrochemistry, physical and transport properties, and solution chemistry of molten salt and room temperature ionic liquids. He has published more than 110 referred journal articles on these topics and holds 5 patents about technology based on ionic liquids. In addition, he is the author or co-author of several book chapters and edited volumes about molten salts, and has co-organized 3 Electrochemical Society International Symposia and a Gordon Research Conference about molten salt chemistry. He is a fellow of the Electrochemical Society and has held many national committee appointments with the organization. For more than a decade, he has served as associate editor of the Journal of the Electrochemical Society. During this period of service, he has taken more than 1,000 submitted manuscripts through the review process.
So I think maybe we should make this very casual.
Yes.
So if you have specific questions, in general, and if not, we can tell you a little bit of tips, but if you have specific questions, we can start with that.
One specific question I have is, what do you do if your research ends up coming up with negative results? How do you go about, what's the best way to publish that or get a research paper out of the work you did?
That's a really good question. First of all, you obviously have to make sure that the negative result is indeed negative and that the technique is not detecting a difference. So you really have to do that. But after you do that, it really depends how you spin it. So, for example, and then unfortunately, people are not gung-ho about negative results. So let me give you actually an example that happened to me. For my PhD dissertation, I found out that corals have symbionts in them. They have algae that live within them. And I found out that the algae, the genotype of the algae, basically the same algal partner stays in that host forever. It didn't seem to change either, over decades and over time, or if you transplanted them. And that's in some ways nothing happened, right? But the ramifications of that are really important, because that means that if global climate change continues, these things will not change partners, they'll potentially die. Well, I submitted that to Science, and one of the reviewers said it would have been so much more interesting if they had changed. And so it ended up actually, long story short about that, it ended up coming out as an article in a marine journal, but the follow-up article to that was reviewed as an editor's choice in Science, so revenge is sweet. But the bottom line is you have to put the spin on it. So if it means that, for example, in my case, that the partners will never change, and that has huge ecological implications, then that's really, really important. And in fact, negative results are very important, because if you don't publish your negative results, somebody might repeat that same study, not knowing that other people have published it. So it's all, and it's not so much I'm not saying this in a negative way. You have to sell your science, and I'm not I'm not making it trivial or belittling the process, but you have to sell the science. So you have to show how such a negative result is really, really important and will contribute to the field. And if you put it in that light, then it's an important result.
The basic fact is you shouldn't be discouraged. Try to look at it from a different angle. And negative results are not that good, but they have a value. So, but the basic fact is never get discouraged. I know it's easy for me to say at this point, and if there are times that you wish the whole thing started with someone, other person or advisor or another topic. Just forget it for 2 days, have another shot at it. The basic thing is don't get discouraged and don't fight with your advisor. I can't stress that enough. There are times, when, frankly, in my case, I didn't talk to the guy for 6 months, but in the 6 months I ignored him, but I did my work. So
I think it's important to realize that when you go in to do an experiment, try to figure out something, try to prove something, that you make a hypothesis, and you test that, and you hope that you can prove it, since it's something that you feel about strongly, obviously. And then it doesn't work. Well, it's all a matter, I think Dr. Goulet said it best, stepping back and looking at what you've done. You may have proven something else. So there really isn't negative results, because even negative results are positive. They're telling you something else. And so maybe you need a new hypothesis about what you've proven. Waste nothing.
As long as it's solid science, it's good.
in fact, negative results have the potential to be very positive if you get a second look at it, step back, have another look at it, and whoa, here's something you didn't know, nobody's ever said. And so it's not bad to give it another thought. And don't forget, you are the best person at present, having worked on your thesis for so long. You're probably the best person to analyze it, look at it in another perspective, and stuff like that. So don't be disheartened. I know you get disheartened for a while, but that's human nature. But try not to get disheartened.
And I'll just add one more thing. You have to also be creative in how do you look at your data. And this builds on what was said in terms of you had a certain approach or a way of looking at the question, which is why you approached it this way. But perhaps your paper should be a comparison with what, like a broad review if one has not done that, or like comparing what you found to other systems, or some kind of new twist, so that it's negative in this system but it's positive in that system, and why is it like that? And so that it may not have been your initial goal of why you set out to do this, but now you're packaging it in a different way, and that can be really informative.
I think that's particularly true for mathematical problems. I know I was in India years and years ago, and I got stuck in a problem. And a guy from Purdue, chemical engineer from Purdue, Dr. Ramakrishna came. He said, "Why don't you look at it from another angle?"
Exactly.
Exactly. And whoa, it just opened up. Instead of going at the same thing over and over again, step back is important, and then look at it from another angle. And it was lovely. So I do owe him the paper, but I never said so. But you do have to step back and look at it from another aspect. Of course, if you really get negative, then you're stuck. But it's an initial negative result or an initial block is not that difficult. Just step back, look at it from another viewpoint. Who knows? You might be lucky. But again, coming to the point, don't get disheartened.
Some other questions?
Alright, so with the internet now, there's so much literature out
Yeah.
whatever your field is. And so it's like, I can't read 1,000 papers and need to really make sure I read everything. So when is the stopping point to thorough research?
Never.
Sorry, go ahead.
But one of the things that I see as an editor that is disturbing to me is that a lot of young people coming into science are not taking the time to go back and look at what has been done before them. And I have been at conferences where someone got up, a young person got up and gave a presentation on something that exactly what we did in 1984.
But it wasn't in the electronic database, so they didn't pick it up.
So they never picked it up. People don't take the time to do that. And I try to train my own students with limited success to take the time to do a thorough literature search. And I do it myself. I mean, I'll spend a week, 2 weeks, 10 days obsessing over and following a trail back through the literature to the paper that cited the paper that cited the paper, till I get to the original person who may, in one case, was 1937. But that point is that that's where the theory in question began. And I really urge you to be successful, to impress the editors and the reviewers, to take the time to make a very thorough literature search. And as Dr. Goulet said, if it isn't in the electronic database doesn't necessarily mean that it's not existing somewhere. Certainly, you can use the electronic database to trace things back and find a jumping off place where you may have to actually, shock, get up and walk over to the library. Yes.
But I would add though that so when I was a graduate, I'll tell you a quick story. When I was a graduate student, I saw a fellow graduate student who was defending before me, and so I said to him, "So are you finished?" And he's like, "You're never finished, but you're done." So at some point, you will start to see that the literature is not as, it's tangential perhaps to your point, or people are repeating it. And you also can't have a list of 50 references for every sentence that you say in an article. So you'll get a sense that you've covered, as long as you've